So the first step will be to clean these plates. Grab a bottle of hexane. And hopefully they're more flat than the previous ones. Grab an extra Kim wipe. It looked like there was some white solid residue sitting on those plates. They were probably not properly cleaned last time they were used. Just wipe those off with hexane. If we have that little bit of crystalline material on there, you see it kind of on the edge of the plate there. That'll prevent it from sealing tightly. Could run into some problems. Definitely some solid on there. Better to clean them right after you use them, of course. Yeah, that one looks like it's pretty good. Trying to hold by the edges. Hopefully those are going to seal together fairly tightly and give us a nice film. So, now that we have clean IR plates, we can continue with the process. We're just going to take a drop on the stirring rod, set that in the middle of the plate. We'll turn that, we'll get some NMR when the instrument works. We're just putting that on there to create a nice film, and that really did spread out very nicely. I woke this instrument up earlier, so we're going to collect a background. And I checked and it's empty, so we're good. Notice I'm holding this by the edges so I don't get water vapor on it. There's our CO2 peak and our water and our little bit of hydrocarbon. That's the standard background. It looks great. We don't need to save that. We don't need this. So now we're going to collect a sample. I'm going to go ahead and put the sample in. This one is the one with the two little white edges. Slightly different holder style. So this is DCL-10- what did I say that was? 52B. And this is the first spectrum. And then we will get carbon NMR. That'll be 52B-2. Forgot to take the cap off my camera. Hopefully that didn't affect anything. So I'm prepared to collect the sample spectrum. 4 scans. And we're looking good. Got this big stretch over here. Still got this peak here though, which is probably the carbonyl group. And that's not particularly surprising, since we almost certainly had a little bit of ketone, and those didn't separate nicely. So we can move this text down, and by double clicking up here I can add the comment that says this is purified 2-methyl 1-phenyl cyclohexanol. At least that's what it's supposed to be. after silica column. So we'll OK that. Baseline's pretty stable. I'm not going to bother correcting it. I am going to change my display limit though, because I don't need to see from 400 to 600 because that's where sodium chloride absorbs. And I'm also going to change my y-axis limits. I'm going to start at -5 so that when I label peaks I've got a little bit of leeway down there on the bottom. I'm going to move this guy so he's out of the way of everything. And now would be a good time to save this data. File name to title. Now I'm going to find peaks. I don't know if I want that. I think I do. 1601. Yep, that peak's real, so I'm going to keep it. Let's replace. And then I can use my little text tool to move these peaks around so they're easy to see. Kind of off scale, we'll move them where we can see them. This guy's all the way off scale, so I'm going to have to actually change my display limit. Make it -10 on the start. And I'll be able to grab that peak. And that one's actually important. 1492. Columbus sailed the ocean blue. I don't know if that peak at 1109 matters, but it's labeled, so we'll leave it. This isn't necessary, really. I'm just trying to get all the peaks. That 862 really doesn't matter. I do want this peak, though, and I can't get it. So we're going to change that display limit to -15, maybe -20, to make sure I can find it. There it is, 755. That peak matters. Now I can go back and change that display limit, make it -15, so we fill the screen. Oh, stop you. Got 2 minuses in there. Here we go. So that looks decent. That peak at 633 I'm just going to delete, because that's in the sodium chloride area. And this sawtooth pattern here, I'm going to label those peaks just for the hell of it by using the little T. So that's nicely labeled. Let's save it. And let's print that. ECL-10-52B-1 PDF file. To hell with Windows, recovered from an unexpected shutdown. Somebody must not have shut it down properly. So now let's do a IR spectral interpretation and see what it thinks is there in terms of functional groups. Aliphatic hydrocarbons. There is a cyclohexane ring, monosubstituted aromatic hydrocarbons, and aliphatic carboxylic acids. It's not identifying this peak. This is pretty much the same thing it said for our crude material. I'm going to save that. We haven't gotten really a lot of difference. We're going to call this 52B-1 functional. We can close that window, and then we can do our search. And nothing close match, 76.39 to 1 phenyl cyclohexylethylamine. At least it's got the phenyl and the cyclohexyl, 2 phenyl cyclohexanone, so there's still a carbonyl. Right? We still got that carbonyl peak, which we didn't really want. And the compound is clearly not in the library, so, which isn't too surprising, really. So this is DCL-10-52B-1-search. We can save that. And then we can close everything. And I'm going to shut this computer down so it shuts down properly this time. Maybe it won't have those error messages next time someone uses it. And we just need to clean our plates. Wipe those off to get most of the compound off. And then we just put a little hexane on there. Wipe that off on both sides. Dry them, and we'll leave these plates in better shape than they were when we got them, so the next person won't have to clean them before they can use them. So all that remains to be done on this compound now is to wait until the NMR works again and collect NMR spectra, and hopefully that will be sometime in the relatively near future. Just wipe that spatula off with hexane as well, or the stirring rod rather. So there's the IR spectrum on the purified alcohol.